All right, let's pull back the curtain on the AI magic we're all using every single day. We're going to break down exactly what a large language model is and figure out how it goes from your simple question to a mind-blowing answer. So, let's get right into it.
It really does feel like magic, doesn't it? You type something in, hit enter, and boom, a totally coherent, sometimes super complex answer just appears. Well, it's not magic, but it is an absolutely fascinating process. And we're going to walk through that process step by step so you can really get what's happening under the hood.
So let's start with the basics. What even is an LLM? At its heart, it's an AI that's been put through a massive boot camp, trained on just an unbelievable amount of text. We're talking models like Llama, Qwen, or Google's Gemma. They've basically read more of the internet, books, articles, and code than any human ever could, all just to learn the patterns of how we communicate.
You got to understand that an LLM's life has two completely different phases. First, on the left, you have training. Think of this as its school years. It's incredibly intense, needs warehouses full of supercomputers, and it's where 100% of the learning happens. Then you have inference, on the right. This is the performance. This is what happens on your computer when you ask it a question. And the key thing to remember is, during inference, the model isn't learning anything new. It's just using what it already knows.
Okay, so let's go on a little adventure. We're going to follow your prompt on its incredible journey from the second you press enter all the way through the system to the moment the AI starts spitting out a response.
Here's the basic roadmap of that journey. It starts with your prompt, gets chopped up by something called a tokenizer, then turned into embeddings, processed by the transformer, which is the real brain, and finally, it generates the response. Let's break down each of those steps.
First stop, tokenization. See, an AI doesn't read whole words or sentences like you and I do. It has to break our language down into smaller, manageable chunks called tokens. The best way to think about it is like chopping up a sentence into individual Lego bricks. Each brick is a piece the model can actually work with.
So for a tech prompt like PowerShell script to list services, it gets broken down into these individual tokens. You can see them here, PowerShell script, and so on. This is that crucial first step of translating our language into something a machine can actually begin to process.
So now we've got our Lego bricks, our tokens. But how does the AI know what they mean? Well, that's where embeddings come in. Each and every token is converted into a long string of numbers, a vector. It's kind of like giving each Lego brick a very specific address in a giant, multi-dimensional library, where similar concepts, like king and queen, are grouped closely together. This is how the AI starts to understand language using pure math.
Okay, so our prompt is now just a bunch of numbers. But how does the AI understand the context, the meaning behind it all? This right here is the secret sauce of modern AI. This is what makes it all work.
The big breakthrough is something called the transformer architecture. See, older models used to read a sentence word by word, and they'd often forget the beginning of the sentence by the time they got to the end. Transformers were a game changer because they look at all the words at the exact same time. This was a massive leap forward, allowing them to finally grasp nuance and complex relationships in our language.
And the engine inside that transformer is a mechanism called self-attention. Honestly, if you remember one thing, remember this. Self-attention is how the model figures out which words in a sentence are most important to the other words. It's how it builds relationships.
Right, so in a sentence like this, the self-attention mechanism immediately knows that server and memory are super important for understanding why it crashed. You can think of it like a spotlight. The AI shines that spotlight on the most relevant words to figure out the real cause and effect.
Now, as you probably noticed, not all models are the same. Their power, their capabilities, it all comes down to a few key things. Their memory, how much they know, and just how big they are. Let's dig into that.
First up is the context window. This is basically the AI's short-term memory. A small 2K window means it can't remember very long conversations, but a huge 32K plus window, that can handle enormous documents or really long detailed chats without forgetting what you talked about 10 minutes ago.
And next, we have parameters. If the context window is short-term memory, then parameters are the model's long-term knowledge, everything it learned during training. Models can be small, at around 1 billion parameters, or just massive, at 70 billion or more. And yeah, more parameters usually means better reasoning, but it also means you need way more powerful hardware to run it.
So that begs the question, how on earth do we run a giant model on a regular computer? Well, the answer is a little trick called quantization. A normal 7 billion parameter model is about 14 gigabytes, but after you quantize it, you can shrink it down to just 4 gigs. It's an amazing compression technique that's making local AI a reality for all of us.
But of course, there's always a trade-off, right?
The more you compress it, say down to a Q2 level, the more quality you might lose. Q4 is a really popular choice. It's a great balance of size and performance. And a Q8 is almost as good as the original, but it's going to take up more space. It's all about finding what works for you.
All right, now for the really fun part. You are not just a passenger here. You can actually get behind the wheel and start tuning the AI's personality and how it behaves using just a few settings.
The most important setting is probably temperature. The best way to think of it is as the AI's creativity dial. Turn it way down to like 0.2, and you get very factual, predictable answers, perfect for writing code. Crank it up to 1.0 or higher, and the AI gets way more creative and random, which is great if you're brainstorming.
So, here's a pro tip for all you tech folks out there. For coding or scripting, try these settings. Set your temperature low for stable, reliable answers. Use a top P of around 0.9. This just reduces weird, off-topic outputs, and set a repeat penalty of about 1.1 to stop it from getting stuck in a loop. Give it a shot.
Okay, that was a lot, I know. So let's boil it all down into one simple mental model that you can easily remember to understand how this whole thing works.
When you strip away all the complexity, this is it. Your text goes in, the tokenizer turns it into numbers, the neural network does its thing, and then, and this is the absolute core of it, it simply predicts the most likely next word, the next token. And it just does that over and over and over again, one token at a time to build its entire response.
And hey, take a look at everything you now get. You understand tokenization and embeddings. You know what transformers and self-attention are all about. You get the difference between context windows and parameters, and you know how to tune the output with settings like temperature. You now have the fundamental building blocks for how modern AI actually works.
So we'll leave you with this thought. Really understanding the machine is the first step to mastering it. And now that you can speak its language, now that you know how it thinks, what are you going to build?